Now because I'm moving my hand in this and this manner, you have not extracted any information from it. So nonetheless, there is because I'm doing this, so I have done some work also, energy would be there, but because you are not getting any information from these kinds of movements of my hand, that piece of energy is not a signal. So main point is that they are the forms of energies. First point, signals are the forms of energies. Next point, signal should be a quantity or an entity. More correctly, it should be an entity, that is the entity which is having some information associated with it. Information part is very much important. Now what signal does? It will depicts, it will show, ये दिखाएगा आपको. What it will show? It will depicts the behavioral pattern. The pattern, क्या तरीका है? The behavioral pattern of some physical or natural phenomena. I must write it. That information would be depicted. This information should depicts the behavioral patterns of some physical or natural phenomena. Now how it could be represented on a piece of paper? Because the phenomena is occurring naturally or physically, or in a laboratory something is happening, that if I'm in a laboratory, I'm doing an experiment in which I'm taking the values of the temperature rising in a particular water or some liquid. If I want to do that experiment, I should be taking these informations from the actual phenomena which was happening over there, because now the water is warming up and then it boils. So it is actually happening. But I want to extract that information that I can visualize. My eyes, these are all sensors. My eyes, ears, everything is a sensor in our human body. So I can measure the particular thing or a warmth of the water, either by looking onto the thermometer, what they are reading, what are the readings of the thermometer. I can sense that I am measuring it. These are the measuring instruments a body will be having. So I will be measuring all the information of the boiling water with the passage of time. At the beginning of the experiment, the water level, suppose say it was 20 degrees, and then it has risen up from 20 to 21, 22, and then it has come to suppose 50. So that change occurs in that particular phenomena by the passage of time, because the real access which we would be having to analyze these phenomena would be time only. But please don't get confusions that signals will be depicted or they can be represented not only by time axis, they can be represented with many other independent variables. Now the question is, if I want to represent the signal, I must represent it in the form of a function, because it's a varying quantity. I have just told you there must be some variation in the quantity I like to observe, I like to depict, because there is a behavioral pattern of that quantity in that phenomena. So that variation has to be represented with a variable. There must be some mathematical variable which should vary, and that variation of that variable is only understood to me if I would be having some other variable which is independent of the variations of that varying quantity. I repeat, to understand the variations of a variable, if this point is moving like this, I must stop this point and observe it from this point, that what is the movement of this point. So it's very important to understand to get some information of a variation of something, I must have another variable which should be independent of the variations of this varying quantity which has been shown by the variable. So I must need an independent variable. So in all of my systems or in all my signals, I have chosen this independent variable as a time, because time is the real axis over which we can perform anything practically. And one more important reason for choosing time is because, now let me write it also, I have taken the function with an independent variable as the time. That should be an independent variable, right? So suppose that is the dependent thing and that would be then independent variable. Now I have also taken time as an independent variable because actually the roots of this subject is in electrical systems. We are discussing the systems which are electrically modeled, because our branch is electrical, electronics and instrumentation. So I would be more concerned towards the system modeled in electrical circuits. And for electrical, suppose if you are from mechanical, then you should be taking your systems, you should be taking your physical systems in the model of mass, friction and spring constant M, B or F or K, if it is second order system. Now if I am an electrical student, I should model that particular system onto electrical equivalent systems. So for those systems, the quantity which should be varying or the quantity which is the energy in that system is what? You should remember it. It is nothing but voltage excitations and current excitations. For an electrical systems, the excitation or the source means energy inside the system, which is having some information in it also. In my particular subject, I would be taking that as an information. So that particular energy format was current and voltages. So in electrical systems, I should be dealing with voltage and current. And because voltages and currents in electrical systems are preferentially taken with time axis only, so that would be the independent variable I have to take to understand signals also. In order to understand that, there is one more important point. Like if you are supposing that you are having all the quantities as a function of time, because in mathematics also you have studied function with the independent variable time only. But you have to remember that when you are studying electromagnetics, at that particular point of time, you should be taking magnetic field strength or electric field strength as a function of space, x, y and z. Magnetic field density at a particular point. Now that point would be in the spatial coordinate systems, that is x, y or z. So there is one more point. The independent variable could be other than time. It could be time or other than time also, like in this example. And it could be more than one. It is not necessary, it is not a must condition that a function should vary with one variation. It may vary with more than one variations. So to represent those variations, definitely I would be needing more than one independent variables. In that case, it's very obvious that I need more than one independent variable. Now, to illustrate this, I am giving you an example. These are the examples for single independent variable. You must be knowing it. I would be taking example of more than one independent variable now, which is nothing but a photo or a picture signal. If you take it, a picture signal would be represented with abscissa, that is x, and ordinate, that is y. With these two spaces, a point would be there, and the movement of this, all the array of this point on x and y coordinate respectively will frame a photo. You have a speculation, you have an image in your brains with these points joined together, and you are recognizing that pattern of spatial points as a beautiful picture. Your brain is combining all those points, spatial coordinates. All the spatial coordinates of those points are collectively framing a signal which is called as picture. Your brain is visualizing that particular points combinedly, and you have a photograph, a picture. Now, so for photo or picture signal, you would be having these two independent variable. If I talk about video signal, now there are two spatial coordinates like in photograph, but that spatial coordinate is also moving. These points are very fastly moving with respect to what? Time. So if this picture signal, these points start moving with respect to time, and you would be having another axis as time, and definitely a picture could be visualized as a moving video. Moving frame of these points, moving frames is nothing but a video. I should say it like that also. So if I would be adding this independent variable onto x and y, I would be having another signal. I would be having some information also, because something is moving. My brain is taking every piece of information distinguishedly. So if I will be dealing with y, x and t, means I would be having another signal which is nothing but video signal. I will be having video signal because of this time axis. So a video signal will be x, y and t. So it is a three-dimensional signal pattern. That is a two-dimensional signal pattern. Now the question is, up to what dimensions I would be having signal? Yes, the answer is as many as you want. There could be n dimensions to represent n number of variations. And why not? Why you are thinking that for a particular piece of information there is only 2 variations, or there is only 3 variations? There could be 4 also, there could be 5 also. So in a summary, I should write it in this manner, that there could be n dimensions for a signal to represent any piece of information. So there could be n dimensional signal also. Now let me summarize all these things together. if I would be taking signals that are actually electrical signals, now one more important point, these electrical signals were voltages and currents, right? Now the way they are behaving in an electrical system, that behavior would be named as a different kinds of variations, because these are the variations of electrical pulses or voltage pulses in an electrical system. So I would be naming them according to their variations also. Suppose in a particular systems or in your house, you can visualize it, you can see it. A voltage of 220 volt is coming from last 1 hour. So I would be taking this kind of pattern. A fixed voltage value is coming from 1 hour. I would be having no variations in this quantity. I would be having this pattern. So that behavioral pattern of the voltage in that particular duration of time would be taken as step variation. If the voltage or current is coming in this fashion, now it is coming, it is linearly rising. If it is linearly rising, if this is the current, linearly rising with time, I would name this variation as a ramp variation. This is a ramp variation. We will discuss it later also. Suppose if with respect to time you are having sudden rise in the voltages level, or currents will be current surge, which you are called as flickers in currents, instantaneous rise would be there for a short duration of time like this. It's a very short duration of time. This duration is very short. That is still. Now if you are having sudden very high surge in your current or voltages in an electrical system for a very short duration of time, I would be naming this pattern of the voltage or current as something else. So what you are getting? You must be getting this in this manner. These names, these step signals, ramp signals, or this signals, they are nothing, but they are the variations, they are the behavior of a certain quantity, of a certain variable which is varying in a phenomena. So I must summarize these all together. So I must define signal as a entity which is having some associated information in it. First point, it is a packet of energy. You should always remember this. Signal is a packet of energy. It must have some associated information in it. It depicts the behavioral pattern of some physical or natural phenomena that is happening around you. It depicts the behavioral pattern of some physical or natural phenomena. It can be represented with the help of one or more independent variables. That's all. So at least these words should be remembered while defining any quantity as a signal. I should write them. That what are the words, what are the key words you should remember while defining any signal. So signal is a packet of energy. It must have some information associated information. This is very important. That depicts the behavioral patterns of some physical or natural phenomena, and it could be represented, it should be represented as a or with one or more independent variables, right? So these are the main points you should remember while the definition of any signal is asked in an interview or in your examination paper. Now, after defining signal, I must give you few examples of how to represent these information or these phenomena, right? So let us start with the examples of these signals.
If you really like the video, please hit the like button, share the video, subscribe to our YouTube channel and press the bell icon for the latest updates. Thank you.